screen here and like toggle back and forth between our Google Sheet because we'll need that. I'm going to skip through a lot of this. In fact, I don't even think we do part 2 on 10.2 when we talk about regression, okay? I think we're skipping part 2. There's like a part 2, I don't know if you can see where it starts. Yeah, right there, okay? Yeah, so we're going to skip through a lot of this, and then we're also going to do a homework problem together. So I'm swapping the homework problem out for the notes. You're welcome, right?
Yeah.
Here we go, basic concepts of regression. Now we're going to focus in more on the regression line that is created. So like when you plug it into your Google Sheet, it will spit out an equation that looks like this. They write it backwards. If you can remember, like from algebra, like the equation of a line is y equals mx plus b. They, for some reason, when it's written like this, the m part is here and the b part is here. So they put b plus mx. It doesn't matter which way you write it. If you want to write it this way that you're used to, I am fine with that. So there is that, okay? They have a bunch of really long, ugly formulas for finding b1 and b0. We're going to have the computer do it for us. The computer do it for us. All right, so in example 1, it says use technology to find the regression equation. We've been talking about chocolate consumption and like the Nobel laureate rate, whatever, like that data. And that table I have over here. So it was like X was, I should label these. X was chocolate. And this was Nobel Prize, whatever, Nobel laureate, whatever that is. Okay, there's that. And we've got that data plugged in here. Is that the right data? No, that's the data from the last homework problem that we did. Does somebody have their 8-1 notes? Or not 8-1. 10-1 notes, so they can give me that table again. Let me plug it all in. Okay, let's go back to the table. The table was, these were the smaller numbers. My chocolate numbers were 5 and 6 and 4 and 4 and 5, and delete that bottom one. Okay, and my other ones were 6 and 9 and 3 and 2 and 11, and delete that bottom number. Okay, so it spit out this for me. And in the last section, we dealt with the R pretty heavily. Why can I not move you over? Come on. Recording this way slows my computer down because it doesn't do what I want it to. Whatever. All right, so we dealt specifically with the R value, 0.632. Write this down on your page, on your notes. R equals 0.632. And I think that's R squared, actually. Move him over. R squared, 0.632. Okay? Then, R squared. So somebody tell me what the R is. If you take the square root of that. Do that real quick. I'm going to write down the equation. Y equals 3.64 x. And then it says plus minus 11.3. I'll show you where I get that from. Does we have the R?
It's 0.795.
0.795? Okay. All right, so there's the number that we got, okay? Those are the pieces of information that they spit out on the top here. I don't know if you can see this chart very well. I can't zoom in very good. Right here at the top. So 3.64x, that's like mx plus b, but b is negative, so minus 11.3. That's where I get that formula from. So that's where you will need to get that, okay? So when you go to create your chart from your scatter plot, do that. It will spit out this equation, and then we're dealing more specifically with plugging numbers in and using that equation to predict other things, okay? So after we've determined that it has a linear correlation, we're plugging into this thing and we're spitting out other numbers, right? Okay, X has to do with the chocolate, and Y is the Nobel laureate rate, okay? So, just so that we are clear, that's how that works. Okay? All right. Example 2. Refer to the sample data given, blah, blah, blah. Find the equation of the regression line in which the explanatory variable. Okay, so this is part of what I'm going to skip over, but they're going to spit out an equation for us in example 3. In example 2, they don't want me to just use these 5 data points here. They want me to go to the back of the book, which has like 40 points, and plug it in and find the equation. Now, they've done it for us. They give us that equation in example 3, and it is this. Y equals negative 3.37 plus 2.49x, okay? And if you write that backwards, we wrote it the other direction. Let me write it the right direction. Hold up. Do 0.49x minus 3.37, okay? So there is a little bit of a discrepancy between the equation that we got up here and the equation that they got down there. But this is only based off of 5 data points versus this is based off of like the 40. Which one is better?
40.
The 40, right? The more data you have, the more accurate your equation will be. So we're gonna do our calculations with this one, but just know that like that's where the discrepancy lies, okay? All right, so there is that. Now we're gonna go to example 4. We're gonna plug some stuff in, solve for some things, and then we're gonna go to the example on your homework assignment, okay? So they spit that out for us, okay? In example, we're gonna do just 4A, and we're gonna solve for what they want. It says, by the way, mark this again. X was chocolate, and Y was the Nobel rate. Okay? Just so that we're clear and we know which variable is which. Use the chocolate Nobel data to predict the Nobel rate, so I'm trying to find Y, for a country with chocolate consumption of 10K per capita. So I'm going to plug 10 in for X and solve for Y, and it's just that easy. This is like basic algebra. You're plugging 10 in, subtract 3.37, and we get a number for Y. What is the Nobel rate if you type that in? 24.9 minus 3.37 is 21.53 is the Nobel rate. So pretty high, but 10 was a pretty high X. Most of our X's were 5s and 6s and whatever else, right? So they're just using that to do predictions, okay? Let's go to, I'm going to go to example.
Whoa, can you go back?
Oh, sure. I'll stay there for a second.
Forgot your homework.
Yep, we're going on to the homework. We'll do maybe like
Okay.
number 1 and number, the first one at the top of each page. How about that? Okay, together? So, number 1 up here, it says that they give you, they don't even tell me what this data is for. They just say X and Y, and it says use the given data to find the equation of the regression line. So we're trying to find Y equals whatever X, and then plus or minus whatever, right? That's what we're trying to find. Examine the scatter plot and identify a characteristic of the data that is ignored by the regression line, okay? Which means that if they just give you the regression line and don't have you look at the scatter plot, like what's actually happening with the scatter plot that you wouldn't know if you didn't look at the scatter plot, okay? So that's what we're going to do. I'm going to type those numbers in. Let me put them all the way to the top so I can type them in. And I'm going to put them right here. So here we go. Give me just a moment. 14, 5, 9, 7, 11, 8, 4, 12, 6, 10, and 13. Okay, now the other one's harder. Here we go. 10.83. Check and make sure I'm typing these in right. And that I'm not screwing something up. There we go. Okay, got it? Typed in, this is what my little graph looks like. Okay. All right, so it's spitting out this top equation. I'm going to write down the r squared and what the equation is. So here we go. R squared is 0.698, and R is, tell me what that is if you take the square root. 0.6 0.835. What's considered the best R?
999.
Actually, 1 would be absolutely the best, but like anything that's close to 1 or like 99, this is only at 83. So, I mean, whatever. It's decent-ish, but not the greatest, all right? The equation, I don't know if you can see this from down here, but it is 0.7x and then plus 3.5. That is the regression equation that it spits out. So, we needed the equation. Now, the second thing says, identify a characteristic of the data that is ignored by the regression line. So, it gave me a line. Should this thing be a line? Look at where the dots are. What does that look more like? Go back to algebra. it's quadratic. It's a parabola. It's going like a hill up and down, right? Like that's what it looks like. So this should not be a linear function. If we tell it to do a quadratic regression, we're not going to. But if we say make me a parabola or a quadratic equation instead, it would probably be a better fit. Does that make sense? So the characteristic is should not be linear. Okay, looks more quadratic or looks more like a parabola. Okay, what other things do you not know until like you look at the data probably? There's one other thing that I'm thinking of. Like that we probably wouldn't know, like it would spit me out an equation just fine, but what would we not maybe know? Not necessarily, like in the equation. It's going to spit me out an equation no matter what. What about like an outlier? I probably wouldn't be able to see that until I actually looked at the scatter plot. True? So sometimes that regression equation is going to take that outlier into consideration no matter what. What we probably should do is get him out of there before it gives me my regression line, right? Because that's going to alter my regression line. So that's another thing that could happen. So there's 1 and 2. Got it? Go to number 4 on the back side. All right, we're talking about chest size and weights of several bears. Do you think chest size and weight are related to each other? The size around and then how heavy the bear is? Yeah, probably. Okay, so chest size and weight. They want to know what R is. We can find N right now. What's N? 6. Okay, the fish value that they give me is 0.05. Okay, so 0.05. Let's figure out where these numbers are on our chart. This is the hypothesis test. We go to this little skinny chart. And we say at n equals 6 and at 0.05, what is my little mark? 0.811. That is what's deemed to be acceptable. And negative 0.811. Okay, so do you remember what we put for our null and alternative hypothesis?
0.
P equals 0 and P is not equal to 0, right? If P equals 0, what's that mean? If P is close to 0.
It's not.
0 is a bad correlation, right? So this is no correlation, and this is yes correlation. Now, just dealing with the variables that we have, chest size and weight, do you think those are going to be related?
Yes.
I'm going to say that we're probably going to end up circling this one, right? And like rejecting the null hypothesis, we'll see. Okay, we have to calculate what the t value is over here. T. Is it T? No. Is it T? I think they call it T. What do they call it? T equals.
Oh, this.
Yeah, that guy from 10-1. From 10-1 stuff. That formula is R over the square root of 1 minus R squared over N minus 2. There we go. We got to calculate him. But I need my R value, which is going to come from here. Okay, I'm going to get rid of all this data. And it's going to say no data. Nope, I just can delete it. Okay, so we've got chest and we've got weight. Chest and weight. Here we go. The chest size, 50, 41, 45, 52, 45, and 45 again. The weight, 321. Is that how much a bear weighs? Is 300 pounds? I thought it would be more than that. 265, 335. What? Right. These must be baby bears. I don't know. Okay, so there's my data for these bears. That's what he looks like. Okay, the R squared, I'm going to write him down up at the top here. I don't know if you can see over here. I'll put him lower here and move him up. Okay, my R squared from this chart right here is 0.837. Okay, which means regular R. 0.915. Is that decent or not decent? That's pretty decent of an R. Okay, all right, let's calculate T. Oh, let me write the equation down. Y equals, I'm going to put him right here. Oop, right down there below. Y equals 9.84x. Do you know where I get this from? Like, can you see this? I know he's really small on the screen. That same place as the R squared. It gives me the equation for it. So, 9.84x minus 170. Okay, let's go back, hop over here. T equals R which is 0.915 over the square root of 1 minus, we already know r squared. I might as well just leave it 0.837. And n minus 2 is 4.
4.56.
4.56 for that whole thing.
I don't know. Let me check.
I mean, it sounds about right. That sounds, I'll give you that back.
4.53.
4.53.
Yeah.
Okay. All right, but that still means he lives over here, which means we cross off the top and we circle the bottom, which means yes, there is a correlation between the two, which we said, right? We anticipated that. But now we're going to use that to answer a question real quick. It says, use the significance level to determine whether or not chest size and weight are linear correlated. So we're going to say reject H naught. Yes, correlation. Instead of like saying the claim is true, claim is false, I usually say yes, correlation. All right, then they have me do one more thing. Then find the best predicted weight. Which one was weight, X or Y?
Why?
Y. They want me to find Y. If a bear with a chest size of 44 inches, okay? So I'm going to plug 44 in for X and have it spit out 9.84 times 44 and then subtract 170.
262.96.
262.96, and that is in pounds. 262.96 pounds is what we are estimating. Now, they say, is this result close to the actual weight of 213? Not terribly. We said that there was a correlation, so it should spit out a number close to 213, but the correlation is only 91, like 0.91, so it's not going to be great. It's not going to be exact. So I'm going to say kind of close, but not exact. Does that make sense? I mean, it's in the ballpark, 262 and 213. That's like a 40-pound difference. So it's giving me the ballpark for the poundage of this bear, but it's not going to be exact. Okay. Now the reason why they do this is like these bears are all anesthetized, which means they're sleeping, and they're real big. So it's probably not going to be like easy to weigh all of them because like they're laying somewhere, and to like get them on a scale might be harder. So I could just strap a tape measure around each bear. Might be easier to do the chest size, and then I can use that to figure out what the weight should be, right? So there's that. All right. So same thing as what we were doing in 10.1, but then you have to answer some questions on top of that. Got it? There you go. That's all. Okay. Goodbye, people.